Greedy algorithms, something you may not have realized it, but you probably use in your everyday life. Our definition, we make locally optimal choice at each stage of solving a problem with the intent that this will result in an optimal solution for the whole problem. In many problems, a greedy strategy does not produce an optimal solution, but in many cases it produces a good solution in a reasonable amount of time. We might call this a heuristic, a rule of thumb, an approach that gives us a good solution, but not necessarily a perfect or optimal solution. Some specifics, when we go to formalize this, we start with a candidate set from which a solution is created, then a selection function that chooses the best candidate to be added to the solution, a feasibility function that's used to determine if a candidate can be used to contribute to a solution, an objective function which assigns a value to a solution or a partial solution, and a solution function which will indicate when we have discovered a complete solution. And we'll go through some examples on this because this, of course, makes it seem very involved. And in fact, it's something you do pretty intuitively. So greedy assumes something called a greedy choice property. That is, if we make a series of greedy choices, which are never reconsidered, we'll end up where we want to be at our goal. And they also need to have what's called an optimal substructure, an optimal solution. This assumes that an optimal solution emerges from a subproblem's optimal solutions. We assume that the system has no emergent properties. So classic example of an emergent property. Let's say I have two modules or methods that I've written that I've coded for a solution, and they have to work together. So I test each of the two modules, and each one seems to work well, and I then try them together. Will they always work well? Well, no, actually, sometimes they don't work well together, even though they worked just as they were supposed to independently. Greedy is more of a process thing, so it assumes that we make a good choice, and then we make another good choice and another good choice that we will get to our goal. Let's look at a nice concrete example that you do all the time. A cashier needs to give a customer 41 cents and wants to use the fewest coins possible. And the cashier has quarters, dimes, nickels, and pennies. Greedy approach. Try the largest coin until that would produce a negative result, and then move to the next largest and repeat. You do this all the time. So we take our 41 cents and we say, well, what if I try taking a quarter out of it and starting by giving them a quarter? Well, that leaves us with 16 cents. So far, so good. And we might think about using another quarter, but of course that would give them more than the 16 cents, so we don't do that. So we take the 16 cents and we take out a dime. That gives us 6 cents. And we don't take out another dime because that would put us too much. So instead, we take out a nickel, and that gives us a penny left. And then we throw in a penny to finish getting to the change that we owe the customer. So we're done, and we needed 4 coins, 1 quarter, 1 dime, 1 nickel, and 1 penny. It seems easy and intuitive. What could work better, right? And we think we get the right results every time. And in our day-to-day life, we do. But let's try 41 again, only now we're going to be in a country that has coins worth 25, 10, and 4. So we begin with our 41, and once again, we take out 25, and we get 16, the biggest coin. And we take the 16, well, there's no point in trying to take 25 out again, that won't work. But we can take out the 10, and that gives us 6. So far, so good. Now we take the 6 and we take out a 4, and that leaves us with 2. But what do we do with the 2? With this set of coins, we are stuck. But we could have done this. We say, well, you picked something that didn't have a solution, but it does have a solution. It just isn't a greedy solution. We start with our 41, we take out our 25, we get 16. So far, so good. Now we take the 16, and instead of taking out the largest coin that we can manage, which would be the 10, which would be the greedy approach, we take out one of the 4-cent pieces. That gives us 12. Then another 4-cent piece giving us 8. Another 4-cent piece giving us 4, and a final 4-cent piece making all the change. We are now done, and we did need 5 coins, 1 25 piece and 4 pieces. But we had to give up on the greedy strategy, and we had to think ahead and look at the fact that taking 10 out, while it worked, would set us up on something that we can finish. Let's try making change again. This time we'll try 14, but now we're in a country that has coins worth 10, 7, and 1. The greedy approach actually does work. We take our 14, we remove our 10, and we've got 4, and we remove 1, and we remove 1, and we remove 1, remove 1. In the end, we use, for our change, we use a 10 piece and 4 1 pieces, and that does work. It uses 5 coins, and one of our goals was to use the fewest coins. Or we could take our 14 and we could skip the fact that we have a 10 piece, even though that does fit into the 14. At this point, we've diverted from our greedy approach, and instead we use a 7, which then sets us up to use one more 7. This works, and it uses only 2 coins, but it's not a greedy strategy. Hopefully, you now have an intuitive sense of what I mean by a greedy strategy. It's probably a bit better on you, a little easier on you than the more formal approach I pulled out of Wikipedia. So what happened? Why are we surprised? The US and many other countries use what's called a canonical coin system. These are designed so that a greedy strategy will make change using the smallest number of coins. In fact, you might have thought when on our second example, when it didn't work, well, the problem isn't the way I'm making change. The problem is they have a broken coin system, and you could argue that's the case. So a canonical coin system, as used in most countries, is designed so a greedy strategy would work, but this isn't true of an arbitrary coin system, including the 2 that we just looked at, and you can come up with any number of others that doesn't work that way either. We are so used to this greedy way of making change, it is hard to think that it doesn't always work. How about playing Scrabble? We want to make words from our letter tiles, and the best result is to use all of our letters and have none left over. A greedy approach tries to use the most letters on the first word. So let's take an example. Given the letters D, O, G, L, E, T, and S, what can we make? Well, with the greedy approach, our best shot is the word for the first word is doges. A doge, by the way, was the ruler in ancient Venice. He was called the Doge. So if we have more than one Doge, for instance, all the Doges through history, that would be the Doges, D-O-G-E-S. It's a pretty good try, and it uses 5 of the 7 letters, but it leaves the letter L and the letter T. We're leaving points on the table. Optimal, we could use the word dogs, D-O-G-S, and also the word let, and that would give us a score with no letters left. A better approach than the greedy approach for this problem. Here's another one that's commonly considered to run against greedy: hill climbing. And by the way, I'm going to discuss this in terms of physical hills because that's the most intuitive. But a lot of mathematical modeling, we end up with shapes that are like this, that have peaks and valleys, and we want to find some kind of an optimal point. And that kind of problem is referred to as a hill climbing problem because we can model it based on climbing a hill. But suppose we're in hilly country and we want to climb as high as possible. A greedy approach says start up the steepest path, right? If you want to end up on the top of something, go up. This will get you the highest, the biggest gain on the first step. And of course, at that point, it's very likely on the next step as well. But suppose the area we're in looks like this diagram and we're starting at position A. If we take the upward path, we'll end up at small m, which we've gone uphill, but we haven't hit the highest peak by any means. Instead, we have to go the other way. And it's a little hard to tell here, but you may even have to go down a bit before you start coming up. And this is the sort of problem that rattles a lot of modeling approaches, is they have some model of something they're interested in. It might be prices in the stock market or whatever, and they're looking for the biggest gains, but you can't just necessarily start where you are, right? You can't just start by looking around locally. What are the adjacent positions? You have to look at the global picture, which a greedy approach doesn't do. In the extreme, we can hit a dead end. If we want to go to the moon, we could start by climbing a tree, right? We want to go to the moon, so we say, what I want to do for my greedy approach is I want to lessen the distance between myself and the moon. I want to get closer to the moon. If I do that over and over, I get closer and closer and closer to the moon. Eventually, I'll reach the moon. So one approach is I can say, gee, if I climb the tree, I'm closer to the moon. But when we reach the top of the tree, we're not at our goal. And we'll have to climb down the tree and start experimenting with rockets if we actually want to get to the moon. Conclusion. A greedy strategy is a formalization of something we regularly do in everyday life. We might say that it's common sense. If you want to get somewhere, start walking in that direction. Henry Thoreau, in his famous book Walden, suggests that it is quicker to start walking than to earn the money to buy a train ticket. This approach often works, and even when it doesn't deliver an optimal result, it may well deliver good results using reasonable effort. So, greedy approaches come up quite a bit, and they're often a good solution, but not always. And we might even consider, to look at the big picture, something called the J curve. And by that we mean not just the shape of the letter, but the shape of life. It frequently seems in the Christian life that we must be brought low before we can be lifted up. We are humbled before we are exalted. And even Jesus had to die before he could be risen. There is even a book called The J Curve, Dying and Rising with Jesus in Everyday Life by Paul Miller. So the greedy strategy is not the end of the story. It's not the be-all and end-all of getting where we want to go. And with that, I would just end by wishing you a happy Easter.